All right. And so now we're going to switch gears a little bit and talk about vector-borne disease. And so again, a number of great questions about vector-borne disease. And so I can't really attribute too many of them to any one person, but a number of folks raised this question about, is it better to focus control on the pathogen or the vector? And effectively, would we really miss the mosquitoes and the fleas and the bats? And Evelyn specifically asked, how does one balance the conflicting goals of disease eradication and maintaining a healthy ecosystem? Because the vectors are, at some level, part of the world around us.
So I work in rainforests around the world, had the good fortune to do it in many, many places, and these are places which are under immense threat and have been reduced in size considerably. I think as a society we don't care. The very famous ecologist E.O. Wilson has made this point repeatedly, and most recently saying that we should be storming the streets and rioting at the loss of this great heritage, but we don't care. So I think we have lost biodiversity. We continue to lose biodiversity. We don't care about the loss of biodiversity, whether that's a rainforest or a mosquito. I think we would care even less about the mosquito.
But at some level, we are trying to reduce disease, and so what are the costs and benefits? I mean, is it more beneficial from a public health standpoint to target the pathogen, to target the malaria pathogen, for example, rather than the mosquito itself?
So I would say, kind of related to this also, I think one important thing to keep in mind is that we are not going to manage to eradicate mosquitoes. These things, these vectors, we've tried hard, and nature is maybe fortunately stronger than us. So we had enormous rollout of DDT in the 60s and 70s and we talked about this in some of the lectures, maybe for a year or two. That was very effective. Malaria was virtually eradicated from Sri Lanka, for example, in the late 1960s, because of DDT just was knocking out all the insects. Of course, with that kind of chemical treatments, within a year, the resistance crops up. And so I think it's an interesting bioethical issue about how we should balance these things. I think it's a very interesting question. But in reality, these vectors, they're here to stay. So for that reason, I think finding ways certainly to target the pathogens is an important thing to do. But maybe I think a great avenue is to try to reduce the effectiveness of the vectorial capacity of the vectors without imposing these very strong selective pressures. And so
yeah. So this was another question that came up by some others on the discussion forum: are there mechanisms for making the vectors less effective without killing them outright? Right, and I think as a simple example of that would just be bed nets for mosquitoes, right? If you protect yourself from coming in contact with the vector gets to stay alive, and we reduce the transmission of the disease. And so I think there are a lot of potential benefits to those kinds of mechanisms.
In a way, when you have so many components involved in ultimately an infected person becoming disease, and you have vector and environment preventing that, and also preventing the vector from becoming infected. So when you spread that out, it seems like it should make it easier to ultimately, have some combined strategies.
They're more viable targets.
They're
right?
more viable targets here than instead of these very direct, deterministic infections. If you fail, it's all over. But in this case, there's lots of ways. And, just some very simple things, like not leaving pots of water outside your house, screens on the window can have can decrease the burden for mosquito vectors. We're talking about mosquitoes here. I consider bats vectors. Okay?
Well, they can.
They're reservoirs. They have their infectious agents.
Sure.
Those things spill over, but they're not necessarily part of the transmission cycle. For any of the infectious diseases that we're mainly concerned about.
I think it's worth bearing in mind that for the mosquito vectors of diseases like malaria, we've done a remarkably good job of eradicating them through these interventions such as screens and water and better drainage. And the great examples are in Italy in the 1900s and Florida in the 1940s and 1950s. And they're remarkable. We can do that elsewhere. The problem is, of course, we don't focus enough attention on doing that. And I think I made this point in one of the lectures that as a society, we spend more money on curing male baldness than we do in controlling malaria, which is a very nice factoid from Bill Gates that I appreciate immensely. And I think it's true. So we have examples where interventions such as disruptive technologies, such as bed nets and screens and removing water can be remarkably effective. So we have a good lesson, again, repeatedly, from history, which we could adopt should we want.
I think the question is very insightful also, though, in addition, because it does raise the question of whether there are other things that we can do to the mosquitoes. And of course, there's been... So the reason why a lot of the obvious solutions to controlling this hasn't worked is that when you're killing mosquitoes with insecticides, you're creating such a strong selective environment that evolution will happen. And so there's been some interesting work on trying to think, well, so as it turns out, particularly for malaria, but also for many viruses, it takes a very long time for the parasites to develop inside the host. And so if you could develop some kind of insecticide that just shortened the lifespan of the vector by a relatively small fraction, then the mosquitoes would be relatively happy still, because they're only reducing their lifespan by let's say 20% or something like that, which means that the selective pressures would be relatively low, yet the parasites would be unable to complete their life cycle inside the vector during that lifespan, so that you could effectively render the vector population incompetent of transmitting the parasite, yet not forcing it to evolve for these interventions to become useless. So that's really interesting. And then I think there's been other interesting work on using microbes.
Yes, so all insects, just like us, have microbes, and one really interesting one is Wolbachia, which apparently is in 76% of all insects sampled. And Wolbachia is what's called a reproductive parasite, so it affects the ability of a male and a female to mate, and it also can have some other effects, such as changing the sex of the insect from male to female. And being a reproductive parasite, it provides some clues into ways in which we might control it, and people are using this now. And there's actually field trials in Australia to prevent, control the transmission of dengue. Scott O'Neill has done some really beautiful work in there, and some people here also work on just messing around with the microbiome in ways that we can offset and control the ability of these vectors to transmit. Really exciting areas of research.
Because an interesting thing is that in several cases, there's documented now that certain strains of these intracellular Wolbachia bacteria actually can prevent the mosquitoes from being susceptible to dengue virus and to malaria, certain strains of them. Yeah. And these microbes seem to be able to spread quite effectively into wild population of mosquitoes. So that's
there is sort of there's a macro level to this system as well, right? So a number of these will work, that we can regulate the water supply, that we can put up our screens, that we could wear self-protective gear, or we can, that also varies in a dimension of how much individual people will need to play something out, or that we could have one community that puts something in a plane and just distributes it without getting anybody's permission. And we tend to move from this political level more and more recently to the ones that won't need individual level buy-in, that won't need individual level work, with a concern that, well, how could we get everybody to do something? In the long term, that can be moving us further and further away from all these other creative mechanisms that also work, or even just knowing that there is a portfolio of options, and just, limiting ourselves to the ones that we can stick in a plane and just shoot over an area.
All right, well, thanks everybody, and we'll see you next week.